An exoplanet found by Hubble telescope resembles the reputed Planet 9, Planet X in our solar system. This is by University of California at Berkeley. Astronomers confirm bound orbit for planet far from its star, showing that far-flung planets do exist. Astronomers are still searching for the hypothetical Planet 9, Planet X Nibiru in the distant reaches of our solar system, but an exoplanet 336 light years from our Earth is looking more and more like the Planet 9, Planet X of its star system. Planet 9, potentially 10 times the size of our Earth, and orbiting far beyond Neptune in a highly eccentric orbit about the Sun, was proposed back in 2012 to explain perturbations in the orbits of dwarf planets just beyond Neptune's orbit, so-called detached Kuiper belt objects, and it has yet to be found if it exists. A similarly weird extrasolar planet was discovered far from the star HT 106906 in 2013, the only such wide separation planet known. While much heavier than the predicted mass of Planet 9, Planet X Nibiru, perhaps 11 times the mass of Jupiter, that's huge of course, or 3,500 times the mass of our Earth. It too was sitting in a very unexpected location, far above the dust plane of the planetary system and tilted at an angle of about 21 degrees. The big question until now has been whether the planet called HT 106906b is in an orbit perpetually bound to the binary star, which is a mere 15 million years old compared to the 4.5 billion year age of our Sun, or whether it's on its way out of the planetary system, never to return. In a paper published December 2020 in Astronomical Journal, astronomers finally answered the question. By precisely tracking the planet's position over 14 years, they determined that it's likely bound to the star in a 15,000-year, highly eccentric orbit, making it a distant cousin of Planet 9. And if it is in a highly eccentric orbit around the binary, this raises the question of how did these planets get out there to such large separations, said Mage Nguyen, a recent UC Berkeley graduate and first author of the paper. He said, were they scattered from the inner solar system or did they form out there? According to the senior author Paul Callas, University of California, Berkeley, adjunct professor of astronomy, the resemblance to the orbit of the proposed Planet 9, Planet X, shows that such distant planets can really exist and that they may form within the first tens of millions of years of the star's life. And based on the team's other recent discoveries about HT 106906, the planet seems to favor a scenario where passing stars also play a role. Something happens very early that starts kicking planets and comets outwards, and then you have passing stars that stabilize their orbits, he said. We're slowly accumulating the evidence needed to understand the diversity of extrasolar planets and how that relates to the puzzling aspects of our own solar system, he said. And the young dusty star with a weird planet? HT 106906 is a binary star system located in the direction of the constellation Crux. Astronomers have studied it extensively for the past 15 years because of its prominent disk of dust, which could be birthing planets. Our solar system may have looked like HT 106906 about 4.5 billion years ago, as the planets formed in the swirling disk of debris left over from the formation of our Sun. And surprisingly, images of the star taken in 2013 by the Magellan telescope in Chile revealed a planet glowing from its own internal heat and sitting at an unusually large distance from the binary, 737 times farther from the binary than Earth is from the Sun. That's 25 times farther from the star than Neptune is from the Sun. Callis, who researches for planets and disks around young stars, co-led a team that used the Gemini Planet Imager on the Gemini South Telescope to obtain the first images of the star's debris disk. In 2015, the observations provided evidence that led theorists to propose that the planet formed close to the binary star and was kicked out because of gravitational interactions with the binary. The evidence: the star's outer disk, the dust disk, and inner comet belt are lopsided, suggesting that the planet, perturbed the symmetry. The idea is that every time the planet comes to its closest approach to the binary star, it stirs up the material of the disk, said the team member Robert de Rosa of European Southern Observatory in Santiago, Chile, who's a former UC Berkeley postdoctoral fellow. He said, so every time the planet comes through, it truncates the disk and pushes it up on one side. This scenario has been tested with simulations of the system with a planet on a similar orbit. This was before we knew what the orbit of the planet was. The problem, as pointed out by those simulating such planet interactions, is that a planet would normally be kicked out of the system entirely, becoming a rogue planet. Some other interactions, perhaps with a passing star, would be necessary to stabilize the orbit of the eccentric planet like HT 106-906b. Callis went looking for such by a flyby star. Last year, he and De Rosa, then at Stanford University, reported finding several nearby stars that would have zipped by the planetary system 3 million years earlier, perhaps providing the nudge needed to stabilize the planet's orbit. And now, the precise measurements of the planet's orbit between 2004 and 18, Nugent, De Rosa, and Callis present evidence that the planet is most likely in a stable but very elliptical orbit around its binary star. Now, in addition to confirming the planet's 15,000-year orbit, the team found that the orbit is actually tilted much more severely to the plane of the disk, between 36 and 44 degrees. As its closest approach to the binary, its elliptical orbit would take it no closer than about 500 AU from the stars, implying that it has no effect on inner planets also suspected to be part of the system. That is also the case with Planet 9, which has no observed effect on any of the sun's 8 planets. What I really think makes HT 106-906 unique is that it's the only exoplanet that we know that is directly imaged, surrounded by debris disk, misaligned relative to its system, and is widely separated, Nugent said. This is what makes this the sole candidate that we have found thus far whose orbit is analogous to the hypothetical Planet 9, Planet X Nibiru type of thing. And this is on SciTech Daily by University of California at Berkeley. Very interesting, isn't it? Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.